And now I would like to introduce our first guest, Danny Smith. He flew in from Atlanta representing AWS. Welcome, Danny.
Welcome.
Hi.
Gen AI is your big topic today. Gen AI for industrial application. Do we a little bit overestimate Gen AI?
Probably.
Probably. Okay,
Yeah.
we will see what you will tell us. Thank you very much.
Thank you. So hello, everyone. Good morning, good afternoon, good evening, wherever you are in the world. Thank you for having me. Let's dive in. I have 3 topics that I'm going to spend time with you today. I want to talk about current trends. I want to talk about the rise of generative AI. We get into some use case examples, and then I'm going to close with important considerations and key lessons that we've learned over the last 18 months or so. So let's dive in. So most people in the audience, I'm sure, are familiar with traditional machine learning. Traditional machine learning is where you, as an example for computer vision, and some of my colleagues, guest speakers, will talk more about this later. But you can train the model. You can say, this is a good image, this is a bad image. And then when you run a prediction, maybe I get out of the way, then you can see what's predicted, and you understand the probability of the prediction being right, and you can make a better decision. This is traditional machine learning. So my question, though, is do you think you're using traditional machine learning enough already? Right? So there's many different places in the greater supply chain or value chain where you can use traditional machine learning to make better decisions. But I don't think we as an industry are using this enough, right? So let me give you some reasons why. So this is a study from Manufacturing Leadership Council. This is an organization of companies that are learning about and progressing the idea of Industry 4.0. They did a survey, interesting results. There's a link to the survey. You can take a picture and take a look. You know, one of the questions I asked was, where are you using it? So I'm just highlighting at the bottom where there's very little penetration, right? And so if you look at these, like supply chain, finance, sales and marketing, human resources, it's like this is where all the humans are that are doing the work in our organization. Like the group that does the most with traditional machine learning or AI is in manufacturing. But if you look at the larger organization, you see that it's lightly penetrated. Let's look at some other information. So here is another survey question they asked, and they said that, well, most of them are experimenting, right? So we only have like 1/4 of the companies actually having AI within, productionalized, sorry. So still lots of opportunity for traditional machine learning. This is always an interesting one. It's like, so what's the biggest problem? Data, right? But I don't think it's lack of data. I think we have lots of data. We have sensor data, telemetry, et cetera. But if you ask what's the problem with data, it's about contextualization. So this is an area where Gen AI might actually help. Because it's not the data, it's understanding what the data is telling you, and then communicating that to a human for the human to make better decisions. Let's keep going. So a couple of other things from the survey. Most companies expect there to be significant impacts to the workforce. But if you notice, 2/3 of the respondents didn't budget for this. So I guess they're hoping that the technology will take care of this themselves. Maybe Gen AI can help. So the last thing I want to say is that, look, Gen AI is not a magic button, a magic wand. There are things it can do and things it can't do. This is an analyst report. And at the bottom, we highlight, it says, look, Gen AI may not be able to do certain things. But interestingly, traditional machine learning might actually do these things. And so if you look at generative AI and traditional machine learning in combination, you might be able to get to where you need to be. All right, so let's talk about generative AI. It's different than traditional machine learning. So here's an example. So generative AI, there's like text to text and text to image. And this is an example of predicting the next word in a sentence, right? So this is what large language models do, right? So in this example, students open their, what's the next word, right? Well, if you look at the entire internet, all of what's typed in, right? Or if you feed all this data from the public internet into these models, now you understand the distribution curve of what's the next word in the sentence, right? There's a couple of other things that are important. Like one is which words are important in the sentence, because we have too many words, right, for scale. So there was an important thing called attention, right? It's this idea, so like 5 or 6 years ago they came up with, it says we only have to pay attention to the important words in the sentence, right? So this is generative AI. And so if you take the vast majority of the internet, you run it through these new approaches, you hear the buzzwords, transformers, attention, embeddings. You can look those up, and research them. This is what a foundation model is. And these foundation models are big, right? And so the growth of these foundation models from like, say, 2019 to today is, 3,000 times the number of parameters. So most of the information that's floating around in the public domain is probably in these models. So 18 months ago, OpenAI released ChatGPT. Took the world by storm, right? So here's some of the questions that I want to address, right? It's like, hey, what's the impact? Well, we don't know. How much of it is made up? That's a question. Will it take our jobs away? Are there security risks, right? Could it damage our reputation? We have no idea about any of these things, really. We're learning, right? But the big thing is that we want to adopt it everywhere we can. Right, so let's figure out what's going on with that. Okay, so here's an example of hallucinations, and this is using jokes. So if you look on the image on the left, right, you see, it's kind of made up its own language, right? So they're definitely generating things that don't exist in reality. However, if you look at the image on the right, you can see that it's doing a reasonable job of explaining a joke, right? So while it makes things up, it might actually help us understand things too. Let's talk about the impact on the workforce. So the image on the left is from Bain. They identify a number of industries that may be impacted or the potential for automation. The image on the right is from Harvard Business Review. I'll just highlight like industrial sectors. So there's significant areas of the workforce that are going to be impacted. Now, how they're going to be impacted is kind of an interesting question. And so I'll turn to humor again. Highly recommend Tom Fishburne, he's pretty funny. This is a great example. So we have Gen AI generating an email, and then Gen AI on the other side of the email interpreting what the response is, right? So this is probably pretty true. But if you think about the implications of this, here's one. What if we put two foundation models against each other in a gaming situation to negotiate? So this is something that's worked on now. So the potential is going to be pretty interesting. All right, so are there risks? Absolutely there are risks. This is one of my colleagues. He identified like these sleeper agents. And so the idea is, without explaining this in detail, is maybe you embed some risky things into the training material so that later on, somebody with a smart prompt can take advantage of it. The potential is there, right? And so one thing, did you notice that Google bought or negotiated with Reddit to use all of their training data? I don't know if you guys spend any time on Reddit, but Reddit can be pretty weird. So this may or may not be good, right? The key thing, though, is that data is the value. So we'll talk about that in just a minute. All right, so can Gen AI damage your reputation? I don't know if you saw in the news recently, but an airline in Canada, somebody asked about a funeral, discount, and their chatbot said, "Oh yeah, sure." And then later on, it found out that that actually was made up. So take a pick. So absolutely, all these things, are things that happen or are things that are concerned about generative AI. And where are we now? We're at the peak of all these expectations. But why is everybody so interested? So everyone's so interested because, well, one, people like McKinsey are saying, oh, the potential is millions and millions and billions and trillions of dollars, euros, et cetera. If you dig into the detail, what you'll see is that there's a lot of people who think that large chunks of time can be, or large chunks of employees can be helped, right, accelerated, made more efficient by generative AI. And this is interesting because if you think about it, in our industry, we've been Toyota Production System, Master Black Belting, Lean, Kaizen, et cetera, improving processes for decades, but we haven't really spent time improving employees. So this is why people are interested. Here's just an example of this. So, for procurement, right? If they're looking at using an open source license as an example for development, just ask the questions. Hey, tell me about my options to indemnify my customers if I use this open source license, right? And the response is, hey, if you use this license, you don't have any obligation, but you could if you wanted to. It's a good answer, by the way. Let's keep going. Why is all this so important? Here's a survey from the US National Association of Manufacturers. So this is basically the lobbying organization for the manufacturing industry inside the United States. And whether you are headquartered in the United States or you sell into the United States, most likely any company that is in manufacturing in the world is actually participating in this organization. And they do a survey of their CEOs every quarter for the last 10 years plus. The top priority, the top challenge that the survey identifies from the CEO level is talent, right? So accelerating people, accelerating them into their jobs, pretty important. So look, here are some example use cases from just one customer of mine, right? There's text generation for contracts that I showed you, technical specification assistance for teams that are buying or selling, resolving issues with supply chain, creating synthetic data to do autonomous vehicle and automotive. There's all kind of different use cases. I'm gonna go through a few. So I look at this because I have automotive, industrial, and manufacturing globally as responsibilities. I look at it across big strategic workloads, if you will, right? So software-defined everything, autonomous mobility, smart operations, et cetera. And these different models, you see the use across things, but I'm just gonna pick a small subset, to talk about the top three that I see. And so smart operations is a good example here, right? So coding assist, what I call interactive knowledge, and then these natural language dashboards. I'll highlight those and then give you some other examples. So let's take a peek. So top use case, helping coders code, right? I think everybody understands this concept. It's like you don't want to code, you just want to say, I would like code that does this, right? That's top use case. Why is it a top use case? So here's a study from McKinsey again. They took a look and they said, look, if you have the most complicated code in the world, you'll get an acceleration of 10%. This is embedded code for systems and cars and things like that. If you have average code, your website, et cetera, you can accelerate a coder by 50%, right? That's amazing if you think about that. So this is why everybody is excited about this, right? Just one example that's public recently that came out. So British Telecom, BT Digital, so they started trying Amazon's code accelerator called Code Whisperer. So they ran through about 100,000 lines of code in 4 months, right? They estimate that it helped automate about 12% of these tedious, repetitive, time-consuming tasks. On average, it provided each coder about 15 to 20 suggestions per day. And those coders accepted those recommendations about 1/3 of the time, 37%, right? So it's pretty interesting how fast it can go. And so once they tested that, they said, okay, this is fabulous, and they rolled it out to about 1,200 different coders. So take a look at the article. You can search on it. It's interesting reading. Okay, so here's another top use case. So it's what I call interactive knowledge, or, it's basically asking questions of domain-specific information. So here's one. My daughter's car broke down. Some of the people in the audience have heard this story, right? So my daughter's car broke down when she was going to a final exam. And so, of course, being who I am, right, I get the ODB device, I stick it in the CAN bus, and I said, what are the fault codes coming off of the powertrain? This is actually a real example. So what are P11, P12, P16 fault codes have in common? Right, and we get a good answer, right? So imagine how fast or how much this could accelerate automotive repair technicians or maintenance people in the factory or in the field, or anyone who needs to access technical information. Right now, the way this works, and we'll talk about it in just a minute, is we're accessing a technical document behind the scenes, right? But you can embed this anywhere. So here's an example of embedding GenAI. So Siemens has Mendix, their low-code or no-code platform for development. They announced at CES, so the Consumer Electronics Show. It's fascinating to me that an industrial is the lead keynote at a consumer electronics show. But they announced embedding our product for GenAI inside of Mendix, right? And so there's just some examples here, which to me are really fascinating. Could you change the color to Brazilian flag? It's pretty funny. All right, so here's some other examples, right? So this is Seek, one of our partners. They have an industrial platform. They can add it in and say, hey, I want to model my temperature based on other variables as input, right? Show me how to do it, right? Build it out. So, and I'll just scroll through some other ones. So there are lots of examples, but think about this in broader terms. What if I was just an analyst, right? And I just wanted to say, hey, show me, I want to tell a story with data. Go find the data that I want and then help me build the story and then let me edit it. Like if you think about that, that's really powerful across the organization. So going back to this, 30% of hours automated by 2030 that McKinsey projected, if you think about how fast you can get work done by just not having to go find the report, but just asking for the data, I mean, that'll give you an indication of how this is possible. All right, so let's talk about other use cases, right? Here's a call center. So this is a banking use case because everybody probably has frustrations calling their bank, right? So it's like, okay, so hey, I want to lock my card. So it gives the agent a suggestion for the solution and it tells them how to do it. Some other ones. Here's ladder logic. So I was with some of my co-presenters last night and we talked about, these things aren't trained in school anymore, right? So ladder logic is what controls PLC, right? And so here's an example. So hey, explain the following ladder logic code. Does a pretty good job. Hey, it's monitoring multiple lines for faults. It's looking, if all of those faults are negative, then it'll start the drive. This is pretty powerful across the board, right? Here's some other ones. Show me a comparison between normal and abnormal behavior for the most important sensor readings, right? If we've detected an anomaly, now help me figure out what's going on with the anomaly, right? It's just accessing information for humans in an easy way. Here's a supply chain example. Hey, what products have been out of stock the most lately? So I'm sure you have a report buried somewhere that has 29 different, reports that show this, but wouldn't it be easier just to ask? All right, a few more examples. We use generative design to change the shape of the car, and then we run it through traditional, computational fluid dynamics to understand drag. All right, I'm running out of time, so I want to wrap up in 5 minutes, maybe more. So what I want you to remember, one, you need some choice and flexibility on models, on databases, et cetera, because there's some interesting things going on behind the scenes with GenAI. So 2, your data is where the money is. So we'll talk about that. And then 3, I want to challenge you to accelerate your entire organization. So let's talk about the first one. So here's how you can improve responses. People worry about Gen AI making up things, right? And so most people by now understand prompt engineering, right? Prompt is just a question. Hey, when can I have a meeting? You ask a bad question, you get a bad answer. So a better question is, hey, when can I have a meeting with a particular person? Looking at our calendars. Now, looking at our calendars is an example of accessing other information. Let me talk about how that works, right? So the reason why this retrieval augmented generation is so popular is because it's a middle point between very little cost to, if you build your own foundation model from scratch, that's extremely expensive, right? And you don't want to do that every day. So if you want to give people access to current information, this RAG technique is pretty popular, right? So how does RAG work? Well, here's the question. So, what could cause camshaft problems? There's a chatbot. Behind the scenes, there's an agent mechanism that kind of goes out. The first thing it does, it says, hey, let's go look at data sources, that diagnostic fault code manual. Let's find the relevant things, package it up, and then we give it to the large language model in this case, and that's how we get a good response, right? So this is how you eliminate hallucinations and you answer factually, which is important in our industry. So now there's a couple of things to think about. One, with this kind of architecture, you only need to send relevant information. But two, you don't necessarily need the best model, which is always the most expensive model, right, to get a good factual answer, right? And so this is really important. So let me show you. This is the example I used earlier. If you want to roll out a maintenance chatbot to 20,000 service technicians, and if the quality of the output is equivalent, which often it is, but the difference in models is like the one on the left is 32 per million token. The one on the middle is 3.2, right? A 10x difference. In order to scale, you want to choose the most obvious one. So there's some important things here. Now look, there's some hidden complexity, right, in these models. And so choice of model, choice of data stores, choice of agent mechanisms, this is critical for you to be able to roll this thing out with cost in mind so that you can roll it out to 20,000 versus only 200. All right, wrapping up. If you think about it, foundation models are trained with the entirety of the public internet. So what's left? What's left is your data, right? Your data is where the value is. So a couple of things. One, protect your intellectual property, right? Your data is the value. This is where you get the value. So make sure that you're protecting it. Don't just send things off into a public, chatbot. Make sure you understand what the structure is of protecting your intellectual property. So the second thing is use a modern data strategy, right? So if the value is your data, right, make sure that your data can be accessed in the best way possible. If you're interested in those things and you want to understand how AWS can help, give me a call. Okay, so the last thing, I want to challenge you. This is an example from one of my customers, and they said, you know what? Machine learning is something that we need to just leverage across the entire organization. So everyone, business user, as well as technical people, need to understand it. So how do we do this? So we actually worked with them to create an entire structure, a rollout of upskilling the entire organization. They had a great goal, right? This should be like oxygen for us. Everyone should understand how to leverage it and use it. So my question, yep, here we go. So here's what I want you to think about. How do you accelerate an entire organization? Well, one idea is to give everyone in the organization access to generative AI. All right, with that, I want to say thank you and turn it back over to our moderator.
Danny, thank you very much. It was a pleasure.
Of course.
It was a great presentation. I have one question.
Of course.
What is your opinion? Is English becoming the new programming language? Because we have a big discussion because of NVIDIA the last days. What is your opinion on that?
Well, I think, I started my career, as we talked about last night, right? I was a, engineer at first in university. I learned Fortran.
Yeah.
Then I got hired to do COBOL, which is pretty funny. I'll tell you the story later. And then they asked me if I could use assembler, right? Now, nobody programs in assembler anymore,
Yes.
right? We have simpler things to do. So I think this is a progression of making it simpler for people to take advantage of the technology. One last comment, though. I don't know if it's English, because there are languages around the world that are beyond English. And so if you can use your natural language to describe what you want, and then maybe it gives you code, then you can look at the code and understand what the code does, probably still critical, right? And then you have the solution. So I hope it's an evolution, not a replacement. But I think it stresses that you need critical thinking skills, right?
We will have the discussion at noon, and we will go more details in this topic. Thank you very much.
Of course.
Leave the stage. Thank you.